everyone, and welcome. Today, we're plugging directly into the heart of the internet. We're going to learn the language of network devices, the Cisco Command Line Interface, or CLI for short. And look, this isn't just about typing in commands. It's about having a real, direct conversation with the hardware that connects our entire digital world.
So think about it for a second. A router is this incredibly powerful device, right? It's like a digital traffic cop, directing data at lightning speed. But fresh out of the box, it's basically a paperweight. It has no rules, no directions, no purpose at all. And that's where we come in. We have to give it instructions. And the way we do that is through the command line.
So, how are we going to take this thing from zero to a fully functioning network hero? Well, here's our game plan. We'll start by learning the language, how to actually talk to the router. Then we'll give it a job, lock down its digital doors, and teach it how to direct traffic. And finally, we'll open up the admin's toolkit to see how the pros keep everything running smoothly. All right, let's dive in. Okay, first things first, we've got to understand the environment we're working in. The Cisco CLI isn't just one single place. It's actually a series of modes, each with different levels of privilege. You can think of it like walking into a high-security building. You can't just waltz into the main control room. You need the right clearance for that. So you start out in what's called user EXEC mode. This is the lobby. And you know you're there because of the prompt. See that little greater than symbol? That's your clue. Here, you can look around, but you can't touch anything. To get more access, we type the enable command. This gets us into privileged EXEC mode, our control room, now marked with a hash sign. From here, we can run tests and see all kinds of detailed stats. But to actually change things, we need one more step. Configure terminal. This takes us to the blueprint room, global configuration mode. And notice how the prompt changes every time? It's always showing you exactly what level of access you have. Now, let me show you the ultimate cheat code for the CLI, your secret weapon. If you ever feel lost or you're not sure what command comes next, just hit the question mark key. That's it. The CLI will instantly show you every single command that's available right where you are. It's like having a built-in guide that's always there to help you out. It's a total lifesaver. Okay, so we know how to get around the different modes. Now it's time to give our blank slate router an actual identity. We're going to give it a name and a place on the network, basically turning it from a generic box into a real, functioning member of the team. Every device needs unique identity, right? First, we give it a name with a hostname command. Easy enough. Then an IP domain name, which is going to be important for some security stuff later on. And most importantly, we configure an interface, one of the physical ports with an IP address. That's its street address on the network. And finally, the magic command, no shutdown. See, interfaces are off by default, so this command is what flips the switch and brings the port to life. Now that our router has its own address, it can get its first real job, helping out the neighbors. I mean, how do your laptop, your phone, and your TV all get online automatically? Well, they ask the router for an IP address, and the router hands one out using a service called DHCP. It's that friendly protocol that just makes our networks work without us having to think about it. And you know what? Setting this up is surprisingly simple. First, we just create a named pool for our addresses. Then, we tell it which network range to pull those addresses from. Next, we set the default router. That's the router's own IP, which tells other devices, hey, if you need to get to the internet, come through me. And finally, we give them a DNS server so they can look up websites. 4 simple commands, and boom, our router is now a helpful service provider for the entire local network. All right, our router is up and running. It's being helpful, but right now its doors are wide open. And the single most important job of any network admin is security. So before we do anything else, we are going to lock this device down. These are the absolute non-negotiable first steps. We set an enable secret, which is a strong encrypted password to protect that powerful privilege mode. We set a password on the console port for physical security. Then we run service password encryption. This command just scrambles any other plaintext passwords in the config, which is a simple but really important layer of protection. And finally, for remote access, we enable SSH, the secure shell. This encrypts our whole management session. This is why we never use the old insecure telnet. Seriously. Now let's bring in some real security muscle. Access control lists, or ACLs. Just think of these as the router's bouncers. A standard ACL is pretty simple. It just looks at where you're coming from, your source IP, and decides if you're allowed in. It's like a bouncer just checking if your name's on the guest list. But an extended ACL? Whoa, that's way more powerful. It's like a bouncer who checks your ID, asks who you're here to see, what you're carrying, the whole shebang. It can check source, destination, and the specific service, like web traffic.
So how does the router know which kind of bouncer we're hiring? It's all in the number. As you can see, there are specific number ranges reserved for each type of ACL. So if you create an access list using a number from 1 to 99, the router just knows, okay, that's a standard ACL. If you use 100 to 199, it knows it's an extended one. It's a simple built-in system to keep things organized.
So our router is configured, it's secure, and now it's time for the main event. The very reason it's called a router. We need to teach it how to make smart decisions about where to send data. This, right here, is the magic that makes the entire internet work. See, a single router only knows about the networks it's directly plugged into. To learn about the rest of the world, it has to talk to other routers. And it does this using something called a routing protocol. The best way to think about this is like the router's own personal GPS app. Routers are constantly talking to each other, sharing updates about new roads, traffic jams, and the absolute fastest way to get from point A to point B. Now, there are a bunch of different protocols, but let's look at 3 big ones. RIP is the old simple one. It just counts how many routers or hops it takes to get somewhere. Then there's EIGRP, a much smarter Cisco protocol that looks at things like bandwidth and delay to make a better decision. And OSPF is the open standard version of that, using a metric called cost, which is based on bandwidth, to find the best path. They're all just different GPS algorithms for different kinds of networks.
Okay, for our final section, let's open up the admin's toolkit. Because, building the network is one thing, but keeping it running day to day is a whole other challenge. A real pro knows how to check their work, troubleshoot problems, and maintain a healthy network. These are the commands for that job.
If there is one command you will type more than any other, I guarantee it's this one. Show IP interface brief is the network admin's go-to vital signs monitor. It gives you a quick, clean, at-a-glance summary of every single port on your router. It is the very first thing you check when you hear the internet is down. So what are we actually looking for here? You want to focus on the last 2 columns. Status tells us about the physical layer. Is the cable plugged in and getting a signal? Protocol tells us about the data link layer. Are the 2 devices speaking the same language? Your goal, always, is to see up and up. If you see up/up, you know that connection is physically solid, and the problem is probably somewhere else. But if you see anything else, like down/down or up/down, this command tells you exactly where you need to start looking. Before we wrap up, I want to share the single most important piece of advice for anyone new to the CLI. And trust me, it's a lesson every single one of us learns the hard way at least once. All of that amazing configuration we just did, right now it only exists in the router's RAM. It's temporary memory, which is called the running config. If that router loses power or somebody reboots it, all that work is gone. Poof, vanished. To make it permanent, you have to save it to the startup config. The command is copy running config startup config. You have to commit this one to memory. Save your work, or it just didn't happen. So let's just step back for a second and look at what we did. We started with a completely generic piece of hardware. We learned its language, we gave it an identity and a job, we secured it, taught it how to navigate the internet, and finally, learned how to check on its health. That's a pretty incredible journey, from a simple box to an intelligent, secure network device. You now have the fundamental building blocks to configure and manage the very devices that power our digital world. The command line is a canvas, and these protocols and commands are your tools. So the only question left is, now that you speak the language, what are you going to build?